and I'm a senior web developer with the Cogworks. I'm also an Umbraco trainer, so for those of you guys who sat the examining course yesterday, I wrote that one. And hands up if you got 100%, because you beat me, and I wrote the exam, and I got 90%, so go figure, it was that good and that hard. I'm also a big Liverpool fan. Any Liverpool fans in the house? I was actually going to take this slide off because we're doing so shit at the moment, but what's the alternative? I've become a Manchester United glory hunting fan like Imran there, so but there you go. Okay, so there's even a few disclaimers in this talk. The first is this talk is not about Umbraco, gas, horror, shock, but as Umbraco developers, we write code. And those of you who are not Umbraco developers, and maybe some of you here who have never actually worked with Umbraco, but you may be coders. You may be developing back-end code, or even front-end code, or even CSS, but you're writing code which needs to be readable. So this talk will apply to you. And for those of you who are, well, that's my, so it's not about but those of you who are not developers and project managers, you're managing people who write code, and you're facilitating delivery of a project which is going to go to your clients, and you want to make sure that stuff is of good quality. So it's going to impact you as well. And if you're not a project manager, I'm not quite sure what you're doing here, but you can sit and listen to talk if you want. There will be swearing. It'll be in English because I've not learned any Polish swears yet. But feel free to teach me the odd one here and there. Well, what's shit in Polish? The other thing is, as we're going through this, some of this may appear to be from the school of the bloody obvious. It'll be like, this is so obvious, you know, why is this needing to be talked about? But as you will see, and you'll probably know from your own experience, that it needs to be stated or restated again. So the other thing is that I'm not an expert with this stuff. I'm still a learner driver with it, and I'm kind of learning and progressing as well. But the other thing is audience participation. I know it's the end of the day, but I'm going to be asking you questions, and I'm going to have a bit of a rapport with you, or else I'm going to be dying on my feet. So that's the end of the disclaimers. So the talk itself is what I learned attending a clean code course with the famous Uncle Bob, and that was a few months ago in London. Hands up if you know who Uncle Bob is. Rob C. Martin. I'll just quite a few hands up. For those of you who don't know who Bob Martin is, so he's really big in the developer world. He's been around for a long, long time. He first started coding, in sort of the late 60s with punch cards. He's worked in, huge mainframes the size of this room, working with disks floating on Mercury, and he's been there, seen it, done that. And he's a very strong advocate of clean code and software craftsmanship. And one of the things in this industry is that we write code, we develop, but how many of us actually think of it as a craft, as for example, as builders do? And we've got plenty of Polish builders in the UK, and they're all very good. And it may be that they trade with Brexit, but I don't know about that. But the point I'm making is that in the building trade, you have, so for example, in the UK, we have the Federation of Master Builders, which is like a guild, and it's something that you aspire to, that your craft, you take pride in it, and you have professional qualifications, and you're proud of what you do. You're not a cowboy builder or Mickey the Brickie, as we sort of another name for them. He's also a founding member of the Agile Manifesto, and I'll kind of touch about that as we go along. He's also a strong proponent of the solid principles, which Soren just talked about before. I'll touch upon those again. He didn't invent them, he just kind of collated them. He's a very strong proponent of them. So the course itself was 3 days long, but I'm just going to give you like a distilled version of some salient points which I think are really important, and there's plenty of takeaways for yourselves, and I think it will prove useful to you. So the first thing is answer if you've got a computer science degree of some description of it. It could be a degree or it could be a master's like me. Okay, there's a few hands up. So you've had some kind of formal training. So in that formal training you will have learned how to code, you will have learned about networking, possibly databases, that kind of thing. How many of you as part of that course, actually had a module about writing clean code. Okay, this is good, no hands up, because I'm going to show my age here, but I graduated in '97 with a master's in computing, because I actually came from a background in chemistry. I did a degree in chemistry. It was a waste of 3 years of my life, but that's a different story altogether. But I did a conversion course where within 2 years, within 1 year, they crammed 2 years of a computer degree course. And I learned how to program in a language called Eiffel. I don't know if any of you have heard of that. No? Okay. Yeah, he has. Okay, anyone heard of Bertrand Meyer? No? Okay. He wrote several texts on software engineering and all principles, and so we were taught to program in Eiffel, which is a pure oral language. But even in '97, we were not taught some of the things I'm going to talk about now. And this is one of the things Bob raised as well, that even at the computer science level, which we could consider as being quite fundamental, and you're going to learn all the sort of things that you're going to need to become a developer. That even at that level, these kind of things are not covered. And I recently had a family friend round, and she came with her nephew, who just recently graduated in computer science. And again, I asked him about what he did. Yeah, we did databases, we did programming, we learned how to program Java, etc. But again, nothing on clean code. So, what do we mean by clean code? And some of you may have seen this before, but I think it's a really good example of what we mean by clean code. So over on the left, or on your right, we have what we would consider to be good code. You crack open Visual Studio, you have a look at the code. Yeah, that's good, that's named well, that makes sense, yeah, cool, okay, you could have done that slightly better. And then you have the other stuff on the right where you open it and it is just, what is this stuff? What was the guy smoking when he wrote this? Recently I came across a repo that we inherited, and it was a surprise because it fell into this category. More often than not, we end up with stuff like this. So I was looking through it, and it was, wow, this guy really knows what he's doing. He's doing a lot of stuff with examining and search. And I was learning a lot of stuff myself, to the point where I was actually doubting my own abilities, that, man, this guy is so good, I suck. And it was only until I delved into a few more modules and found a comment referring back to one of my blog posts that, okay, he's maybe, I've done something right, that I've kind of helped him along to do, some of this stuff. But more often than not, we end up with stuff like this, and, we've probably all seen it. But hands up if you've actually been responsible for stuff like this. Yeah? And if you've got your hands down, you're either not a coder or you're lying. But either way. So, I guess the question to ask is, and more on participation here, why do we write W2F code, or what we would consider as bad code? Anyone?
Pressure to deliver.
Yeah, pressure to deliver. That's a good one. Great.
Save time.
Saving time, yeah?
It's not the saving time, but we think it's saving time.
Yeah, okay. Anyone?
Lazy.
Your laziness, okay, that's one. Anything else? Yeah, that's a good one. Alright, so some of them were covered here. The first thing, we don't understand the problem. So it's something, we just first got it. And there's always, when you're a young developer, your instinct is always just that you see the problem straight away, all you want to do is code. Not to step back and actually try and analyze the problem and see what it is you're trying to actually build. Here's another one. How often than not, you're about to start a project, you've heard about some new hipster framework, and you want to use this in your project, and it's going to be learning on the job. To put this into perspective, if you're a bridge builder, how many times would you look at building a new bridge where you're going to try the latest technology which hasn't tried and tested, and because it's got a few projects under its belt already. Ours is the only industry where, and you don't even tell the client, it's just, yeah, we'll build for you. The client doesn't know, the client doesn't even care, as long as the project is delivered on time and it works. So the thing is about the deadline moves, you've got a tight deadline, you've got to deliver, the client wanted it last week, you've got a backlog of tasks that's growing, you've got to get this thing out the door, the manager's starting to pester you because they want to get paid, they want to get their bonus. And then we're rushing through all this and we're making a big mess and we're thinking, no, it's going to be fine, we'll leave the cleanup later, this is going to get sorted. But the cleanup for later never happens. So, a few comments here. This was from Sarah May, who's also big in clean code and a proponent of clean code. That software is messy because it reflects our evolving understanding of the problem as we wrote it. So, again, it comes back to this about, when we rush into things and not fully understand the problem. And the other thing is that the act of writing the software is what drives that understanding of the problem. So there are many times where you start coding something, you think you've understood it, but then you start to uncover different things, new requirements that the client may have, or things that the client hasn't thought about. Or if you're in Agile and you're doing sprints and you deliver something as a demo for the client and they find new things, they get new ideas. So it's constantly evolving. That's Sarah May again. So another diagram as to why we write WTF code. So the deadline's looming, you've got the most urgent feature request ever, you code it in a rush, you ship it, you've got bugs, and at this point your bug, if you're whatever you're using to track your bugs, they're building, and some smart algorithm will come back with, oh, let's do a major refactor, and then you've got another urgent feature request, and then you're in the cycle of doom, and you carry on that way. And the other one, consider Darth Vader as your client, and they're demanding new things. And not at Cogworks, but I have in the past worked for agencies where whatever the client wanted, they got. Regardless of the deadline, regardless of the cost, it was almost always a fixed price project, deadline was fixed, whatever they wanted, they got. So you were getting developer burnout, developers who were working crazy hours, but the product has to be delivered. Thankfully, at Cogworks, we don't do that, but there are agencies and organisations out there where they do things like that. But what we find here at the Cogworks is often not, client comes with a change request, they put it through change, we cost it for them, tell them how much their deadline is going to be off by, and 9 times out of 10, that's okay, don't worry about it, we don't want it. Okay, so here's the thing also, and coming back to the WTF code slide, which is on the right-hand side about us writing things like this as well. That we often think that awful code is written by awful devs, but in reality it's written by reasonable devs in awful circumstances. There's another quote by Sarah May. And it's sometimes we do need to cut other developers some slack, when we do open up a repo and it is a pile of crap. And I quite like this Indian proverb that never judge a man until you've walked a mile in his or her moccasins. I think Abraham Lincoln quoted this once when he was about to send a letter to an army that one of his generals had retreated, but he thought beforehand that I need to think the situation that he was in, and try and get into their shoes, as it were. But over the years, we've seen things which we would like to unsee. Okay, so some of the signs of bad code, we talked about what it is, but one of the main ones is that it takes weeks to do what should have taken hours. A small change, and the manager will even ask you, right, how long do you think it's going to take? A day or two, and 2 days later, is it done yet? Another week, a week later, another month. So what should be one line of change touches hundreds of modules. I saw something good the other day that somebody tweeted, the example of making a change in software. It's a bit like, your front door needs replacing. So you get the builder to come along, he's changing the front door, and you're tapping the bathroom because the springs a leak, and you sort of tap it back again and the leak stops. We find that you change things in one place and then you get unforeseen changes in another place. And this is specifically .NET. If ever you see codes in code wrapped around with .NET regions where people are trying to hide stuff because it's so big, that's a nasty code style. There's something going on there. So it's rigid, it's fragile. You're scared to touch it basically. And you look at it and it is just loads of WTFs per minute. Here's a good one. There's no tests or test suite, and we'll talk a bit more about that later. And the other thing is that internally, no one wants to touch it, because you touch it, you own it. And everyone's scared to touch it because they know that a small change is going to take so long. So, here's the other thing. When you're working with bad code, cognitive load is increased. And what do we mean by cognitive load? It's the total amount of mental effort used on the working memory. So when you're working with bad code, a lot of the time you're actually trying to understand what it does. You're trying to get through the obfuscation of the code. And bad code is easy to recognize. Clean code is hard to write. It requires discipline, courage, and skill. It's not an easy thing at first, but the more you do it, the more you practice, the better you get at it. And there are some people who are born with natural code sense, and I like to call them natural born coders. A good example is Shannon from HQ. You listen to his talks and you listen to the way he talks about code and problem solving. It's you know how they say you can have a man crush on somebody. I have a geek crush on Shannon. Not sure his wife's going to be too happy about that, but there's some people who are natural born coders, and others mere mortals who have to work at it. Others have to fight to acquire it, and it takes practice. So in summary, we talked about bad code. So what is clean code? It's easily accessible to others, straightforward, clear in intent, good abstractions, no surprises, things are well named. And these are some of the most mentioned points after I did some digging around. The author cares for the software and other developers. That implies it's readable and maintainable. It's minimal, it does one thing and has minimal dependencies. And it's good at what it does. And there's no alarms and no surprises. You've not got things hidden in there which are going to catch you by surprise. And why is clean code important? So, how many of you here doing Agile? Okay. What do we mean by Agile? So, one of the definitions is that you're able to react to change. And this is one of the sort of reasons of popularity of Agile, that it's supposedly one of the benefits it gives you is to be able to react to change, client requirements change, software requirements change. So to be able to meet those changes, that's one of the definitions of Agile. But if your code sucks and it's not clean, it's difficult to maintain, you're going to find it difficult to be Agile. And the other thing what it is that if you don't have clean code, you start to accrue technical debt. And this was really good by Venkat Subramanian. And I forgot to mention at the start of the talk, as well as some stuff from Uncle Bob. I've got a few quotes from Venkat, which I just picked up on Wednesday when I was just following my tweets, and Venkat tweeted that he was actually in Krakow for another conference, and he was speaking, and I called him on Wednesday evening. But this was really cool. What he said is that low quality is not technical debt, it's technical suicide. And as an organisation, you're building software for your clients are going to pay you. But if it's crap, if it can't be extended, that looks bad on you. So, the first thing, important thing, with regards to clean code, is naming. And I quite like this quote, which some of you may have seen, that there are only two hard things in computer science: cache validation and naming things. So, one of the main things about naming is to reveal your intent. So, here's something that's been named. Okay, they've got a comment next to it to reveal what it's doing. But imagine that's in a function. So you define it at the top, and then somewhere down here you're working with it. You're going to have to jump back up there to figure out what that key is. And if you've got a whole load of these kind of variables, this is increasing your cognitive load, and this is not revealing straight away what that variable is doing. So, yeah, you see that kind of stuff, and it is, what is it? So a better way of naming that would have been just what it actually is, elapsed time in days. So the name of the variable should tell us the significance of what that variable contains. Now one of the things about sometimes seeing things like, int X, int D and that kind of stuff is that computer science in the early days was mostly mathematicians. Alan Turing was a mathematician, and many of the early computer science pioneers were mathematicians. And so mathematicians prefer single letter variable names, ideally from obscure or dead alphabets. Whereas programmers, our rule of thumb should be use descriptive variable names. The other thing is that avoid disinformation with variable names. An interesting story, on the course, during the lunch break, I was talking to one of the guys, and his name escapes me at the moment, but he works for the BBC, and he's on the team that develops the iPlayer, which is like an online viewer for BBC TV programs. You can stream them, download them, and the software itself is written in Node.js. And he inherited a piece of work that he had to finish off, which had been written by another developer, who then got on and left. And one of the issues that he mentioned to me was that he started working on this new piece of functionality. And the guy had named one of the variables one thing, and to show its intent. He was then calling a function which was doing something that the function said was doing, but it was returning something completely different. And as he's working with this code, he was saying every time I'm looking at this, looking at the variable name, looking at the method name, even as I'm going down further in the code, each time it was slowing me down because I'm having to keep in my mind that the variable name is this, but its intent and meaning is this. And again, I had to rewrite it. Before I could do this new piece of functionality, I had to go back and refactor that code just so that I could then carry on, just because it was actually giving me a headache. So the other thing is that use pronounceable names, because ideally you're going to be talking about this code. If you're talking to the developers, you're going to be doing a code review, but a bit more about that later. Use pronounceable names. Use searchable names. This isn't as much of an issue now with all the IDEs and tooling that we have. It has nice search functionality and tooling to get around with things, but you should still use searchable names. Variable function and class names, they should answer all the big questions. Why it exists, what it does, how it's used. Classes and objects, these should be nouns, these are describing words, so a good thing like customer account. Method names, these should be verbs, these are actions, so give them, we should name them with verbs. Yeah, so this is something from Venkat again the other day, that if you can't name a variable or a function appropriately, it may be a sign that you've not understood its true purpose, which I think is quite good wisdom and a good rule of thumb. Okay, so from naming, moving on to functions. Okay, the first rule of functions, they should be small, we should learn the same. And then they should do one thing, and if they're small, they will be doing one thing. You should try and follow the step-down rule, which is top-down narrative, and I'll show you what that means on the next slide. Ideally, you should have more than 3 arguments. In working memory, you can hold maximum 7 things, and any more than that, you will have difficulty. But they say that 3 is a good number to have for working memory and things to remember. Any more than that, and your memory is starting to decrease as to what you can remember. Here's a good one, that not to use booleans as a control parameter. And what we mean by that is, it's a warning sign that the function is doing more than one thing. So here's an example. So you call in the render method and you pass in a true. First of all, okay, the ID, if you had ID like Visual Studio, you could open the bracket and it will tell you what the name of that variable is. But looking at it directly, render true, what does that mean? And then you've got render false. So this is a clear sign this function is doing more than one thing. So try and avoid passing in rules to actually control the function. Give it another name and then call the other function if you have to. So step down rule. Now this is a bad one. So let's say you open up a class. You've got a public method, but look what the public method is. So what you're going to have to do is go down here to actually look. This is the public exposed method. Okay, I'm calling 3 things. I'm calling addEx, cook, and serve. So addEx. Okay, that's over here. So your eye's going to have to jump to here. Then you're going to jump to serve, which is up there, and then you jump into cook there. Now it may seem like a small thing, but as you're reading through that code, you want to be able to look at that code quickly and straight away follow what it's doing. In this instance, you're not able to follow straight away. You have to jump around. So a better example of that code rewritten would be, have the public method at the top, so this is the first entry point. You can see the methods that are being called, and it's following a top-down rule that your things are in order. Just make it easy for the person who's going to come later and look at that code. And 9 times out of 10, it's going to be you 6 months down the line who's going to be looking at that code. So the other thing is that with a function, if you can extract another function from it, that is doing too much. So do that. Do extract that. Create more smaller functions. And so you only then have small functions each doing one thing. Classes. So again, classes should be small as well. And they should just try and follow the solid principles, which thankfully Soren has expanded on already. I'm not going to go into too much details about it, but just run through, you've got the single responsibility principle, the open-close principle, Soren covered these things, but I'll give the slides later, but Kevin Gilskowski, I think is how you pronounce his name, more about him later, but he's done a really nice quick YouTube video explaining the 5 solid principles with a really good simple example about a guitar amp. Well worth a watch, and I'll put the slides out after this talk. The other important point, which for some people is a bit of a bone of contention, is comments. But I really like this by Uncle Bob, that comments are not a good thing. They should be seen as a failure to express yourself in code. So one of my pet hates is commented out code. And many times when we have code reviews at Cogworks, if there is commented out code, my first comment will be, why is this commented out? Take it out. It's not being used, it's just there, it's just noise. It shouldn't be there. And the other thing is that comments do not make up bad code. Comments can contain lies. Because sometimes you could have written a comment which was made 6 months ago, but the method may have changed, the functionality's changed, but you forget to, or you can't be bothered updating the comment, so that comment has rotted, and it's now giving you misleading information. And it is a good one. Common fallacy is to assume that the authors of the incomprehensible code will somehow be able to express themselves lucidly in comments. This is good as well, that compilers do not read comments, because comments do not compile code, it's just text indicating something. Developers do not read comments. Or it's the last thing they will do when everything else hits the fan. A good example of misleading comments which I saw on Twitter. This now means that if you run into that lift, you're going to have to keep a mental map of what everything does. Here's some good ones. Bob describes this as smart on it. It's not really giving you any meaningful information, but just somebody being smart. There was another one that was something like hammer time or something like that. This is a good one as well. If you were to open up this code repository and you see that code, is it going to give you confidence in working with that repository? Yeah? I used to work with somebody who will remain unnamed, Warren Buckley, who used to do this a lot. It's one of my pet hates. No shit, it returns one. This wasn't him, by the way. This is something I found on the internet. But here's another one. How many of you do not use source control? Good. Use source control. You don't need this stuff. This isn't, the 1970s. I think maybe then they did have source control as well. But in the old days, this is the kind of stuff you would do. I recall the sort of 98, my first job, seeing stuff like this. So as you made amends, you would put these kind of comments in to say that you've made some changes. We recently saw the client who stored procedures. They had something similar. But I can kind of understand it because it was SQL Server 2000 or 2005 or something like that. Yeah, it was 2000. So the actual stored procedures weren't generated out or stored in source control. So I can sort of get, but don't do this. Use source control. So there's a lot of things we talk about which are not valid comments, but there will be times when you do have to comment, and there are valid reasons. Legal comments. So you're selling something and you want to put your license information in there. Your company name, etc. That's fine. Informative comments. So, for example, you've stuck a regex in there, which is doing something, and I saw a good comment the other day on Twitter as well. You never really learn regex; you just learn how to Google better. So that could be a useful comment. Explanation of intent. So it could be a valid reason that you are doing something which is a bit crazy and a bit out there, but there is actually a good reason for it. Warnings. For example, you could be calling a server in North Korea which could die due to power cuts. So if the site or whatever you're working on seems to temporarily or intermittently go down, somebody goes into the source code and sees that, okay, that makes sense. Trump's about to bomb North Korea, so they're saving power and turning the lights off. Another valid comment would be to-dos, because your editor will help you find those to-dos, although usually to-dos or to never will do. What else? Yeah, another thing about comments. So good code is like a good joke. Writing comments is like explaining a joke. Here's another good one from Venkat I saw the other day. That those who can't design are condemned to document. And when he did his talk, he got really irate with this, that he was in a shower somewhere in the US, and that they had this label on the shower. That's bad design, but there you go. So the second piece of this puzzle is tests. Is Callum here? Yeah, you're not allowed to answer this question because you've heard this. So Bob, over the 3 days that we were with him, gave us some really cool stories about loads of different things. And this one I'm going to drop on you now. Anyone know which planet this is? Mercury, yeah. So, planet closest to our sun, Mercury. And in the early 70s, NASA sent the 2 Mariner probes out to investigate this particular planet. And the hardware was programmed in a language called Smalltalk. Anyone heard of Smalltalk? Okay. So Smalltalk is an OO language that's been around for quite a while and has influenced all the other OO languages that have come out of it. But here's the thing. The software for that probe was written using test-driven development. The tests were written first to drive the design. It wasn't test-driven development exactly as we know it with all our tooling, but it was done with test-driven development, and it was done in Smalltalk. And in Smalltalk, there was something called SUnit, and then in the early 90s, Smalltalk died. And there was a number of reasons for that. One of those was that Java came along, because Smalltalk cost money, and Java was free, so it became a bit of a no-brainer. The other thing was that there wasn't as much uptake in enterprise at the time, and within Java there was, so slowly Java took over. But the other thing, which was a comment made by Ward Cunningham, who used to be really big in the Smalltalk community, and he was asked, why did Smalltalk die? And the comment that he made, which is very relevant to what we're talking about now, was that it was very easy to make a mess in Smalltalk. You could be undisciplined, and that was a big problem. What else did I say? So, but the all these Smalltalk programmers eventually became Java programmers, and they brought the tooling with them. And one of them was Kent Beck and Eric Gamma from. Anyone heard of Ganga 4? Design patterns? Yeah. So those two ported SUnit over to Java and became JUnit, and eventually over time came into the .NET world with NUnit. Who uses NUnit? Yeah, but that came from Smalltalk. Anybody know how to program in Fortran? No? If you want a job with NASA, you can become a Fortran programmer, because the guy who programmed the Voyager probes, which are currently almost out of our solar system, it was written in Fortran. The guy's about to retire, so if you want a job with NASA, learn how to program in Fortran. So the point I want to make is that test-driven development isn't something new. But just to sort of hammer this home one more, have a read of that. That a software system can be best designed if the testing is interlaced with the designing instead of being used after the design. Hands up if you think that sounds like TDD. Yeah? Anyone want to guess when that was written? What year?
78.
1968. TDD is not some new hipster crap. It's been around for a while. It's done the rounds, as it were. And things in programming in this game come in and out of fashion. But TDD has been around for a long time. So this is quite good. The legacy code is defined as code without tests. And the other thing with tests is that you will spend less time in the debugger. That as you are debugging, you can basically test your code, you can test edge cases, and you're going to spend less time in the debugger because you've kind of done a lot of the debugging up front. Alright, how many of you are actually doing test-driven development? Excuse me. Is that it? 4, okay. 3 laws of TDD as dictated by Uncle Bob. So, it's the next thing I was going to do is I was hoping there was going to be more hands, and I was going to need to start putting hands down as you are disobeying any of these laws, but I'll do it anyway. So you may not write production code if you're failing unit test. That's me out the window. I try now to actually write the test first, and in some instances I have done it. But ideally you don't write production code until you have a failing unit test. And you don't write any more of a unit test until it's sufficient to fail. Not compiling is failing. And then your third law, you don't write any more production code than is sufficient to pass the currently failing test. And the clean code also applies to your test suite. So that should be also all the sort of rules of clean code, they should apply to your tests as well. Here's an example of that illustrates testing with code. How many of you have climbed? Yeah. When you're being belayed and you are sufficiently trustworthy of the guy who's actually holding you up, you will try crazy things. So you could be just on a really thin ledge, you will try and make huge jumps and all kinds of crazy stuff because you know you're going to fall a feet or 2 feet at the most, unless the guy's falling asleep and you're going to fall over the bottom. But the point that I'm making is that this is what your test suite is. You can then try, play things, add new functionality, and as long as the tests are well written and you've got good coverage, they're going to safeguard you from introducing new bugs as you add new functionality. And the point that I'm making here is, and the thing about the piece in the puzzle with tests, that if you have existing code which isn't clean, if you have a test suite, you can then go back and clean that code, but provided your tests are still passing, you can do that in a safe way and you will do it in a confident way. I quite like this by Kevin Gibskowski. We tried to get him over for the this festival because apparently 3 generations up, his family was from somewhere near Krakow, and he was going to come up until the last minute, but then he decided not to come. But not using unit tests is like your code having unprotected sex. Yeah. Anyway, but with regards to test-driven development within the Umbraco code base, and Tom, remember when I tweeted you? Or I tweeted, anyone know what tests are? And then you sent me back. Is that still up?
Should be.
Yeah. So there's some links there. One is about the sort of test coverage within the Umbraco code repository. And there's also some links to some talks and some samples about how when you're writing code in Umbraco, surface controllers or even stuff with Angular, how you can introduce tests. But I'll give you these slides after, but there's some nice videos and some samples about code, how to do this kind of stuff. Yeah, so testing is the engineering rigor of software development. So whenever software managers or developers say we don't have time to test, you need to think about that. Would a bridge builder boss, would they ever say that, we don't have time or budget to perform structural tests on that bridge? Now you may be saying, but this is just a website. But what if it's an e-commerce website which is turning over hundreds of thousands of pounds? Or what if you're building software for a pacemaker, and you introduce a bug into that? That's somebody's life on the line. So it's not as simple or straightforward just to say that, tests, that's hipster crap, and we don't do that kind of stuff here. Really, your mindset should be that anytime you crack open a code repo and there's no test, that should be your mindset. We won't have time. What are we on? 40 minutes. Okay, I was going to show some code, but we won't do that because we're going to go out of time. Now, one of the things, if you already have code, you've got a legacy code base, has no tests, then to try and introduce tests, one of the things you could do is find a piece of functionality and try and write an integration test to it. It could be like a checkout process or something along those lines. So write something with Selenium, get a test working which covers everything, which could be slow, but gives you the confidence that, okay, this is covered, it's working at the moment. Then go in and start introducing tests, start refactoring the repo, and you can just keep running the integration test every now and then just to make sure that everything's still working. So where to add tests in the repo, there's a good thing that you can do using a test feasibility table. There's more about that in the Art of Unit Testing book, so I won't go too much into that. But moving on to final advice. So anyone here in the Scouts? Is it just me? Oh, Adam as well. So, Boy Scout rule. It refers to the campground that you leave it in a better state that you found it. And it should be a similar thing with the code. When you're working on some new functionality, try and go in and poke around and clean something up. If something's badly named, rename it. If a method function doesn't make sense, rename it. So these little things you can do continuously. If everyone's doing that, who's working in that code base, slowly over time, there's going to be improvements in that code base. And at the end of the day, it's really, you're going to be doing yourself a favour and your fellow colleagues a favour who are also going to be working with that code repository. And again, from Uncle Bob, that the act of leaving a mess in code should be as socially unacceptable as littering. I mean, in some countries, there isn't that. You could leave stuff lying around, drop your cigarette or whatever. But, in most countries, you drop a piece of litter, people will look at you or stare at you or actually tell you off to actually pick up that piece of litter because it's not seen as a socially acceptable thing. So we should think of a similar thing with code as well, that leave it a mess. We should be proud, we should take pride in our work, as it were. The other thing is that, we should try and code as if the person who's going to end up maintaining that code is a psychopath and knows where you live. Now, it's all well and good talking about bad code, what is clean code, but how can we use practical steps to actually try and introduce clean code into our repositories? The first thing we already said is that as you're going along, try and clean up little bits here and there. But one of the things that we have here at the Cogworks as part of our flow is we have, we use Git, Bitbucket, and we use pull requests. Anytime we do a new feature, we do a pull request, we add 3 or 4 people onto that pull request, and they review the code. Initially, when we first started this out, Ali, who's sat there, was a bit eager, shall we say, and had upset 1 or 2 people. But now it's embedded. We're actually all friends. We're all quite good with this. That we will make positive comments. That maybe this should be renamed to something else. Maybe you should try this rather than that code shit. What were you thinking when you were writing this? Be positive. But these little kind of things can help improve the code base. And when I mentioned this to Bob, that we have our own, this is how we do things, he was quite impressed with that we have our own internal policing, as it were, of code, that it doesn't get into the master branch or into our work branch until it's actually gone through some kind of peer review, just to make sure. One is that it will hopefully reduce the chance of bugs being introduced. The other is that it will ensure that somebody else in the team understands what that functionality is, so you're sharing knowledge. But on top of that, you can use that to actually help others to improve their code. So also as part of development, if you can try and do pair programming, peer review, which is with pull requests, and also try and take out, this was from Venkat the other day, which was really good, that in most organizations, most of the time we're busy, but we will have slack time. And if an organisation is good and they value their employees, they will give them time out to actually try new things, try new technology, etc. Freedom Friday we have once a month at our place. But why not also introduce time to take out to actually clean up some technical debt, some code that is bad? So one of the things that I did is, as soon as I came off that course, I identified in one of our code repositories a project, a console application that I wrote. And I went back to it, and there was one test in it, and that was it. And there was a lot of things in there that I didn't like, and I started going through it to try and clean it up while I had slack time. And the code base is a lot better. There's test coverage now, and a lot of the principles that I picked up from that 3-day course I implemented in an actual code base. It was outside of, it was during work time, but it was slack time. I wasn't working on another project. But I thought, let me have a go at that and just try and solidify all the sort of things that I've picked up. So in summary, I think Soren had this on this slide as well, that no matter how slow you are writing clean code, you're always going to be slower if you're going to make a mess, because you're going to be wading through treacle, and 9 times it's going to be you. It's the mess you make, but you're going to end up making the mess for yourself. So in summary, you're responsible for code quality. You need to sort of take that responsibility with your own code, but also with other people's code. When you're checking out other people's code, if you do see little things that seem to be out of place, fix them. Again, use meaningful names for things. Write code that expresses intent. The code should speak for itself. Less comments, less maintenance. Boy Scout rule, try and leave the code better than you found it. Single responsibility code, so the code that you're writing, function, method, class, whatever, let it try and do just one thing. This is the other thing about tests, which Venkat mentioned. Program deliberately with intention. When you're writing tests, that's what you're doing. You're thinking up front of the design. There's something I saw about a comment about Ward Cunningham had made, the creative S unit, that when he does TDD, he does silly things like, the method will be just returning a bool or nonsense data. And somebody asked him, why are you doing this, wasting this time? He goes, I'm teasing out the actual design that I'm playing, and then I'm thinking before, rather than just going straight in and just by my man, just pushing out loads of code. I want to take my time, I want to reflect, let the design fall out from the test. So yeah, try and work on the big picture skeleton, then fill out the details later, get your interfaces out, which Soren was talking about in his talk on solid principles. Try and think about, again, Soren mentioned this, that independent components that can be reused in different places. Master your craft. Practice, practice, practice. And think of it as a craft. Don't think of it as just as a, I'm a programmer and that's it. Think of it as a craft, just as a builder, when they build up. So this was the thing a couple of months ago, my neighbour, they had a couple of builders in building a wall. And I was watching them, they're doing it, they're taking their time, making sure everything's straight, everything's level. And then a couple of hours later when I came back, when they finished, they were there admiring that work, that that's a good wall. And looking at it, it looked nice, and they were taking pride. And so you want to be able to be in that position, that you look back on that code and go, that was the best I could have done, and I'm proud of that code. Not that it's clever, it's clean, it's readable, it's easy to maintain, it makes sense. Somebody else is going to come along and look at that, they're going to like looking at that code, they're going to like working with it. So, final bit of advice to keep in mind, that as a software developer, you're your own worst enemy, and the sooner you realise that, the better off you'll be. Some homework for you, there's a couple of videos, a really good one by Uncle Bob on the future of programming, which covers a lot of these things. And the talk that Venkat gave the other day, 12 ways to make code suck less, covers a lot of things. And some really good books, which is Bob's book on clean code, which is what we covered on the course. Another good one, which is Code Complete, and Art of Unit Testing. I really recommend this book. First couple of chapters it's still worth reading, but a lot of the stuff is done by the tooling, like NUnit. But towards the end, in the last couple of chapters, there's a lot of good examples of how you would introduce testing into a legacy framework and that kind of thing. So, homework for you. Anyone, any questions? Before we do the questions, so we have had some sponsorship from different people. One of them was GitKraken, and you would have noticed the amazing t-shirt was modelled by myself. I've already had one person ask me, can I have a GitKraken t-shirt? If you ask a good question, I will give you a GitKraken t-shirt. I've got a small, a large, two larges and an extra large. So first come, first serve. It's got to be a good question. Yes?
Can you rewind back to the rules of TDD? Because I understood number 1, and I tried to read number 2 and 3, and I tried to read it, and I still don't understand what 2 and 3 are. So maybe you can give me some examples of what 2 and 3 were.
What size t-shirt?
Very rude. Large.
Okay, hold on. Oh, right. Here we go, right. So you
So
don't write code.
That
So,
one, I get that one. That makes sense.
okay.
Don't get that at all.
So it could be that you've stubbed out, let's say, an interface, and then you're calling a method on that interface. So you do, I don't know, customer.save, for example, right? At that point, the test is going to fail because it won't compile, because the save method doesn't exist. But you still run the test. Then you stub out the test method, the save method, so that means that bit's not going to fail. But let's say the save method was going to return something. So you do some value equals whatever, save. But even at that point, you resist the temptation to go into that method and then actually put in something until the test has passed. And there's a reason for that, because on the course we were given some code. It was a Java date library, and it had a test suite. And he said, right, okay, there's the passing test. Refactor this code to apply clean code principles. And probably half the room, including myself, we started following this, and then boom, 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 and got to a point where it was completely failing, and I had to then sort of revert back to try and figure out where it was failing. But this is the thing about it being disciplined, and this is the thing coming back to what Ward Cunningham was saying, that when he does TDD, he takes his time, and even though it looks silly and stupid, it will tease out the design of your whatever it is you're writing. So, and the third one was that, yeah, no more production code, then pass the currently failing test. So if you have that save method which isn't implemented, stub it out and then go a bit further. And then send back, so save, for example, is going to send back a Boolean, just send back that one value, return true, just to get it to pass, and then start stubbing out the actual implementation.
So they're there to try and make you keep going through the cycle.
Yeah.
Not writing too much text and not writing too much
No.
code.
So you're going slowly, you're thinking, continuously thinking. And this is the thing that Bob was doing on the course, that as he was refactoring some code live for us, he was thinking out and talking out his thought process. Rather than just coding away, he was thinking out loud. And you need to do that as well, whether it's think out loud, but just in your mind, question, okay, right, and let it tease out the actual design. Right, you wanted a large, didn't you?
I'd like a medium, but you can give me a large. Because I won't fit a medium anyway. So.
It'll shrink in the wash, unless it's good quality. Yes, Anders?
So, does it, like, you're probably a bit more experienced doing TDD now, but like, does it take more time in a project to do TDD?
Initially it does, and even now, for me it does, because I'm still not an expert. I would say in our organisation, Anthony and then David are really, probably Wukash as well, really a bit more advanced. And within the Umbraco community, I would say Lars Eric, is it? If you watch his videos, the other good thing within the case of Umbraco and unit testing, have a look at the Nexu project by Dave Wustenberg. He's basically got tests for the actual data types and tests for the actual all the Angular stuff. Have a look at that code repo for the Nexu project. There's a lot of good stuff in there. And watch Lars's video and his code samples. And if Anthony runs the workshop again with Lars, it'll be worth trying to attend that as well.
But is TDD for like all projects, like you do it at all projects, or is it like at a certain size you like apply it, or like?
We want to ideally be in a position where we do it with everything, unless it's something so trivial. But even then, you should once you start doing it, it is. I remember seeing something like TDD is like crack cocaine. When you start seeing that red-green refactor, it is really endorphin rush each time as that test is passing. But coming back to the eye opener for me was two things on that course. One was Bob's story on NASA and with the small talk and with the Mariner probes, and this blew me away. That in the 70s they were doing stuff like this, and we think it's something new, but it's been around for quite a long time, and it's done the rounds. And the other thing was watching Bob actually refactoring a code base and giving us a chance to do it, where we had the test already. The code was crap, but we had the confidence to go in and actually update that code because we knew we had the safety of the test suite. And a bit like when you're climbing, you have the safety of the person belaying you. So yes, initially it is difficult, and even now I still find bits of it difficult, and there's a temptation, screw it, just go through it. But as Bob says, You know, you think you're going fast, but the mess that you eventually create is going to slow you down. But I highly recommend the book as well, Uncle Bob's books. But if you also go on YouTube, look at some of his talks. They're really good. A lot of good stories about this industry and the history of this industry. But at the same time, a lot of salient points about writing clean code and that kind of thing. What size?
Medium.
I have a small.
Extra large.
Small.
Extra medium.
What is this? Extra large. It's up to you. Yeah, these two are small. Yeah. Anyone else? Yeah.
I have a question regarding writing clean code. Do you use any kind of tools that help you write clean code, like for example from C# work, like style cops, FX cop?
I once tried style cop and FX cop, and I can't get my head around it. It was too restrictive. But I think if it helps you, yeah, use two.
And any from JS work as well, like JSLint, SLint, or
yeah, we have in the past when we have been writing stuff with JavaScript, we're using grunt and gulp and that kind of thing, and pass it through linters and that kind of thing. Yeah, large.
large.
I think I've only got extra large.
I don't know if it was a good question.
Yeah. No, we need to get rid of these. The last ones are small, so if you're a small and you want to ask a question.
When is your flight? You're not small.
No, I've got. It's at 8 o'clock. Anyone else? Anything? No? Yeah?
How it happened you didn't pass your exam for 100%?
Sorry?
How did it happen you haven't passed your exam?
That's a good question. I have no idea. I have no idea.
What did you smoke?
Yeah, that's a good question. There was one other little thing that I just quickly needed to mention. We've got the final advice, we've got this bit, we had the question. Does anyone want a small? Also, I'm going to keep it. Go ahead. So one more thing. We've just had the Apple iPhone 10, and if you're stupid enough to buy it, that's yours. But I've always wanted to do one more thing. So at the end of the course, somebody asked the question to Bob that, right, I've done solid principles, I've read the patterns thingy, I've done this clean code now. What should be the next thing that I should do to kind of skill up? And he said, learn a functional language. So then at the end of the course, I asked him, I'm coming from a .NET background, C#, I'm thinking of learning F#, and he said to me, no, learn Clojure. And so I've been trying this for a couple of months now, and it's a completely different way of thinking, let's put it this way. And just to how far I've progressed, I think is very happily captured by that. That's me done, thank you.